A transformation is a process or operation that changes the position, shape, or size of an object or coordinates in a mathematical or geometric space. It can involve translation, rotation, scaling, reflection, or other modifications to the original object or set of data. Transformations are commonly used in mathematics, computer graphics, and various fields to modify and analyze data and objects. Translation, moving objects without changing their orientation by a fixed amount in a specified direction. Rotation, turning objects around a fixed point, altering their orientation. Scaling, changing the size of objects while preserving their shape. Reflection, creating a mirror image of objects across a specified axis. Shearing, distorting objects by displacing points along one axis based on their position along another axis. Transformation can apply both two-dimensional and three-dimensional plane. Anyway, transformation, scaling, rotation, reflection drawn on display, just have a glimpse. Scaling could be up scale or down scale. Rotation could be clock or anti-clock. Two-dimensional, 2D, translation is a transformation that moves an object or set of coordinates in a two-dimensional plane by a specified distance along both the x and y axes, effectively shifting its position without changing its orientation or shape. The formula for a 2D translation of a point, x, y, by a translation vector, dx, dy, is nu x equals x plus tx. Nu y equals y plus ti. In these formulas, x, y, represents the original coordinates of the point. Tx, ti, represents the translation vector, indicating how much the point should be moved along the x and y axes. Nu x, nu y, are the new coordinates of the point after the translation. It can be presented in matrix form also. Coordinate will shift to a new position. Given a circle with a radius 10 and center coordinates 1, 4. Apply the transformation with distance 5 towards x-axis and 1 towards y-axis. Obtain the new coordinate without changing the radius. We apply the formula for nu x and nu y, x equals x plus tx and y equals y plus ty. We get nu x equals 6 and nu y equals 5 and draw the point in the graph. Another example, given a square with coordinate point A0, 3, B3, 3, C3, 0 and D0, 0. We have to find the new coordinate applying translation factor 1 at x-axis and 1 at y-axis. We apply translation formula for point A and find out the new x and y value, which in 1 and 4 respectively. We apply the formula for point B, C, D also. Two-dimensional scaling is a transformation that changes the size of an object or set of coordinates in a two-dimensional plane. It involves stretching or compressing the object along both the x and y axes by scale factors. The scaling factors determine how much the object is enlarged or reduced in each dimension. The formula for two-dimensional scaling with scale factors Sx, Sy is nu x equals x times Sx. Nu y equals y times Sy. We also can represent it as matrix form. X and y represents the original coordinates of a point. Sx and Sy are the scaling factors along the x and y axes. Given a square object with coordinate point A0, 3, point B3, 3, point C3, 0 and point D0, 0. We have to apply the scaling factor 2 at x-axis, 3 at y-axis and obtain the new coordinate. We apply the scaling formula for point 8, 0, 3, and obtain new x equals x times sx, which is 0 times 2 is equal to 0, and new y equals y times sy, which is 3 times 3 is equal to 9. We apply the formula for other 3 points. Two-dimensional rotation is a transformation that changes the orientation of an object or set of coordinates in a two-dimensional plane by rotating them around a fixed point. The formula for two-dimensional rotation of a point x and y by an angle theta around the origin 0, 0 is nu x equals x times cos theta, y times sin theta. Nu y equals x times sin theta plus y times cos theta. It is for anti-clock rotation. Rotation can be clockwise too. Suppose a line starting with point 0, 0 and end with 4, 4. We have to apply 30-degree anti-clock rotation on that line and obtain the new coordinate. We apply the anti-clock rotation formula for both x and y, get new x 1.46 and new y 5.46 and plot the graph. Another example, given a triangle with coordinate first point 0, 0, second point 1, 0 and the last one is 1, 1. We have to rotate the triangle 90-degree anticlockwise. So again we apply the formula for anti-clock rotation and obtain new x and y value for first, second and last point and illustrate the graph. Two-dimensional reflection is a transformation that creates a mirror image of an object or set of coordinates across a specified axis. Reflection across the x-axis nu x equals x, nu y equals negative y, reflection across the y-axis nu x equals negative x, nu y equals y. In these formulas x, y represents the original coordinates of a point. Nu x, nu y are the new coordinates of the point after the reflection. Given triangle with coordinate point A3, 4, B6, 4, and C5, 6. We have to apply re-election formula on both x and y axis. For reflection across x-axis x will remain same, but the y will be negative. So we get final points A3 minus 4, B6 minus 4 and C5 minus 6 and we illustrate the graph. Two-dimensional shearing is a transformation that distorts the shape of an object or set of coordinates in a two-dimensional plane by displacing points along one axis based on their position along another axis. The formulas for 2D shearing are as follows: horizontal x shear, nu x equals x plus shear parameter on x-axis times y, nu y equals y, and y shear nu x equals x, nu y equals y plus shear parameter on y-axis times x. In these formulas x, y represents the original coordinates of a point. SHX and SHY the shearing factor, which determines the amount of displacement or shearing. Given a triangle with first point 1, 1, second point 0, 0 and last 1, 1, 0. And shear parameter on x-axis 2 and shear parameter on y-axis is 2. We apply the formula for x-axis shearing and obtain the new coordinate points and illustrate the graph. Now apply the formula for y-axis shearing and illustrate the graph.